Okay, we're going on now to chapter 5. And in chapter 5, we're going to be talking about polynomials. Now, here's a typical polynomial and another. And as they mentioned, they're central to our study of algebra. Later in the chapter, we'll be working with them and learning the rules of manipulating them. So as we go on to topic 1, we'll look at terms and polynomials, degree and coefficients, polynomial functions, graphs of polynomial functions, adding polynomials, the opposites, and subtraction. Now, we don't usually cover this in Math 105, but I'm adding it to give you background. And if you need to review it, here it is. Terms and polynomials. Well, you're going to see things like this, and we've seen it a lot throughout the text already. Let's look at it a little more carefully. Now, we separate terms in algebra by either a plus or a minus sign. So here there's just one term, here there are two terms, and here there are three terms. And they give you a little definition here. Now, if you just have one term, they use a special name for it in which they use the prefix for one, mono, monomial. Two terms, they're going to introduce bi for two, binomial. Three terms, tri for trinomial. And here are examples of monomials. And again, a general term for all of these is a poly, which means many numbers, polynomial. Now, there are formal definitions, and when we think of a polynomial, in order to be a polynomial, a couple of basic rules apply. You are not allowed to have a variable in the denominator. So even though it looks like a polynomial, it's not classified officially as a polynomial because it has terms of variables in the denominator. Now, just regular numbers are fine, but not a variable. And we see it here as well. And we see it here as well. Now, another thing you may recall from an earlier lesson, we could move this x up into the numerator as x to the negative 1. So this x moving up changes its sign of the exponent. So we also say you can't have variables that have a negative exponent in the numerator, because that would move it down to the denominator and meet this other part of the definition where variables are not allowed in the denominator. Okay, so we'll take a look at some of these, and we might be able to go through it quickly. Okay, identify the terms. Well, there's a negative sign, there's a negative sign, there's a positive sign. So this is a term, this is a term, this is a term, and this is a term. So this one has 4 terms. Now, when we look at a term, and you'll see this probably on the next page, and they're just going back to give us the binomial made up of 2 terms, the trinomial made up of 3 terms, and then when there's 4 or more terms, it doesn't have a special name. So these are all polynomials, but these with 1, 2, and 3 have an additional special name. Now, within a term, and I think they're going to get to this later, let's say in this term right here, 7t squared. The t squared is the variable. The 7 is a coefficient, which is a constant that's in front of the variable. Either we've had this before or they will mention it shortly. All right, let's go on to the degree and coefficients. I guess we're getting into it. All right, good. So what's the degree of a term? It's the sum of the exponents on the variable. So the degree of this term would be 2. And let's look at example 2a. Here there's only x to the 4th, so this degree is 4. Here we have x to the 1st, so this degree is 1. Here we don't have a variable, so we say this degree is 0. And then this last one now, we have x to the 2nd. There is a 1 on the y, and z to the 4th. So we add up all the exponents. This is 2 plus 4 will give you a 7. So again, in the textbook, as you read it, it will be going over a lot of this stuff for your elucification, as we say. That is, you study it and review it and master it. Now, when we have a polynomial, these were degree of a term. In a polynomial, we look at the highest degree of any one term. And here they are introducing the idea of a coefficient. That is the part of the term that is the number part, not the variable part. So as we go here, we see the coefficient is 4. Here it's a negative 7. Here it's a 1. It's not written. And here it's negative 8. Now the degree of this first term is 3. This one is also 3. This is 1. And this is 0. So we speak of what is the degree of this polynomial. Well, 3, 3, 1, 0. The highest degree is 3. So the degree of this polynomial would be 3. All right, we also look at what is called the leading term and the leading coefficient. And what we do there is look at the terms. There's 1, 2, 3, 4, 5. We see this one. This is the degree of 2, 3, 4, 1, 0. So again, these are the terms, and the coefficients are the numerical part of each term, and they're listed. And the degree is also listed. So the leading term, by definition, is the one with the highest exponent, and that would be a 4. So 5x to the 4th is the leading coefficient. And the degree of this whole thing is its highest one, 4. Now they're asked to put in descending order, where the highest would be listed first, and then ascending order, the lowest would be listed first by degree. And they give you some examples. Now we're going to take a quick look at polynomial functions. Here this is in function notation. What is the degree of this? Well, there's a 4, a 2, a 1, and a 0. So the degree is 4. The coefficients 5, -6, 1, -7. This is the leading term. Okay, a little quick review. And then we have types of functions. Linear, in which the exponents are only to the first power. That would be a line. Quadratic, when the exponent is to the second power. Cubic, exponent is to the third. Quartic, the exponent is to the fourth. So just some definitions. Every once in a while we'll use that, but not too often. Again, in Chapter 2 in Math 100, we did study a lot about this. So one of the things they wanted you to do is, when they're giving you function notation and they're defining the function, and when you have something like this in a parenthesis next to the letter in function notation, they're saying take this -5 and put it wherever there is an x. And the use of parentheses is probably important so that you get the right answer. So x is a -5 that you will square, becomes a positive 25, but then you apply this negative sign and it becomes a -25. A -20, a -1 adds up to a -46. Now you won't be having practice on these particularly, but in other examples these skills will be involved. Now we're not doing the graphing part. Here they're asking us to again relate to this graph up here, so we'll skip this part too. And we'll skip this part as well. Because you're using a graphing calculator, you're just plugging this stuff in and getting your answer. Okay, that was a quick little review of 5.1.